Greetings! Today I was going to tidy up my work area. I really wanted to, but this turned up in the post. So on the box it says Industrial Automation COX 2.0 45609 times 2 5 to 12 volt E133B hyphen 05 E133B hyphen, okay, that's the, I guess that's the model. And it came straight hot off the press from China, from Guangxi Road, Fengzhou District, Guangzhou, Fujian, China. And yeah, I know what it is, so I have been waiting for this for a while. This is not the first time I got this item, and I guess I'll get into a little bit more detail in a moment. So what those are is those are brushless DC motor driver with speed control. So yeah, there's no more in the packet. They are individually wrapped. Now this is my second lot of those two items, and yeah, the first lot is here. It's almost identical. Well, they haven't snapped off the edge of the board over here on the other one. The board layout is ever so slightly different on them, but the chips more or less is, chip layout is more or less the same. But yeah, those I have learned the really hard way, or I could even say I have purchased the knowledge for the cost of those modules on what not to do with them. And to be honest, as with a lot of Chinese items, even what I bought, so even the knowledge I bought of burning them out, is not entirely clear, because I'm not exactly sure what I've done wrong. So those modules, they've got a switch, clockwise, counterclockwise, a pot, DC input, so that will accept anything between 5 and 12 volts, and 4 connectors for the wire, for the motor, plus a jumper, which is meant to be, you're meant to switch between 3 and 4 pin 3 or 4 wire brushless motor when you connect it, and it's not exactly sure which position this should be in, so I should probably look at the listing and look at a bit more details, because I don't want to burn those out. Here's the listing, and those costed me £3.78 plus per module, plus £1.47 postage. It came from China, from seller SAG222, with 99.1% feedback. And let's look at the description. So here is 5 to 12 volts DC brushless driver board controller for 3/4 wire hard drive motor, and this is what I wanted to use them for. And yeah, there is various pictures of what the board looks like, which is not that important at this stage. And 100% brand new and high quality material, plastic and electrical components, color green and black. The driver board can drive hard disk brushless motor, CD-ROM brushless motor, and so on. The micro 3 wire or 4 wire without whole brushless motor. It have reverse voltage protection, over current protection, phase inversion control, driver voltage DC 5 to 12 volts, working voltage less or equal to 1.5 amps. That's interesting. Speed adjust 0 to 100%. Note: brushless motor line of receiving terminal plate must be pressed. Sturdiness poor contract will lack of phase operation and burn out the chip. board terminals, fixed screw clearance, please use coarser line connected to the board. How to identify 4-line motor public port. Use the resistance of the multimeter star gears, test this for terminal. One of the terminals and the other 3 terminal resistance value of the minimum and equal, so it's COM terminal. Okay. Size 6 times 4.5 centimeter. Quantity 1 piece. Note, due to the difference between different monitors, the picture may not reflect the actual color of item. Thank you. You are welcome. Let's try to work out what's happening over here. So when this jumper is in this position, let's try to work this out, how this should be on or off. Presumably this is the for on or off for one of the modes, so this could be on or off for a 4-wire mode. So when it's in off position, you're in 3-wire mode, or it could be the 3-wire mode on or off position, so when it's in off position you'll be in the 4-wire mode. And it's marked as P4 over here, P1, P4, okay, port 4, so that's P1, P2, P3 and P4. So this the number 4 has got nothing to do with the 4-wire terminal, it's just a 4th connector. So yeah, it's not exactly clear how to use it, and I really don't want to burn another one. I've already killed 2 of them. Mind you, the other 2 came from a different seller, and yeah, they came significantly quicker. And the layout is slightly different, but I was so sad after killing them that I thought, you know what, if I buy another one, let me buy them from a different seller. Not a different seller, but I saw that there was a physical difference between the boards, so I thought, let me try this one, maybe I'll have a little bit more luck with them. So let me look for a brushless motor and see if we can get something spinning. I found a suitable candidate, something small, and hopefully that's not going to burn that chip out, and then we can move. My actual intention is to use it with a hard drive spindle for various projects that I've got in mind, but this is somewhat smaller. This came out of a CD-ROM drive, and it's a brushless motor. It's got a soldered flat flex on here, which we're going probably to remove. And as far as identifying the public port or the common, yeah, the public port here is marked as COM, and we've got A3, A2, A1, so 3 phases. This is marked here W, U, VW in terms of phases, so we can just connect those wires up, and from just looking at it I can see that this is A3, A2, A1, and the last one should be the common one, but I'll just quickly double check. Okay, a few moments later, I think I've got it connected without shorts, and oops, just put it in the device so it stays in one place. There we go. We can put the spindle back on, and let's connect those wires over here. So this is a 4-wire, so common one is here. Then we've got purple, red, and I don't even know what the last color is. Is it pink? Cream? let's call it cream. Now, the last thing before I connect the power and actually try to power spin the motor is I need to work out what is this doing. So maybe let's just do some continuity tests. Right, so this, my deductions are, if this is in the lower position, like so, this should be working with a 3-wire motor. Reason being, this pin is connected directly to the common one, so when we apply this means that the common one is getting connected straight to the pin. Otherwise, that pin I do believe is fully disconnected. Now, it's worth noting on here that people who manufacture this, that's actually true for both modules, the previous one and this one. They've actually ground off the top of the chip, so you don't know what it is. I don't know why they would do that, but okay. Probably with a little bit of investigation we could work out what this chip is, and find some sort of matching product, unless it's some sort of weird, obscure, unobtainable component, in which case the grinding off the face of it is pointless. So because if you can't get it, it's not gonna work anyways. You won't be able to get it. But without further ado, let's see. So we want to do this to negative. So let me move this aside a little bit so I know what sort of voltage we've got. I'm gonna move it down to 5 volts. There we go. It does appear to work. Perhaps it's not so visible on the camera, so let's make a small modification to the motor spindle. There we go. We added some red, we added some blue, and just for kicks, I can add a little bit tape onto side of it, but that's gonna fly off very quickly, I suspect. Anyways, let's power this back up. Now, this motor doesn't want to start by itself. But once, for a moment I thought I killed this one too. But once I move it off the spot, maybe it's just the matter of this motor, I can get it spinning really slowly. Okay, I stopped and started the camera again, just there we go. This is whizzing away. Let's see how slow we can spin this. Before it stops. It's producing quite interesting effect on the camera, but this is maybe 5-6 RPMs right now. No, stopped. Okay, and yeah, this is probably as slow as it goes. But when I speed it up, yeah, that's at 5 volts, and that's drawing 300 milliamps. And the motor's got a reasonable amount of power, but this is a really tiny motor. Let's see if we can up the voltage a little bit. 6 volts. Oops, I think I killed it. No. Oof, I thought I'd killed another module. But okay, that seems to be working as expected, so fantastic. So now I should test it with a 3-wire motor, what I had before, and what actually killed the previous modules. I think this module is quite a bit more robust, but yet to see with a 3-wire setup. But as far as this goes, on my last attempt with the previous modules, it was dead by now. It didn't even last this long. So let's take this out of the way and let me get the hard drive spindle. Okay, so here's my hard drive spindle connected. This is, as you can see, this is a 3-wire motor. So we've only got red, green and blue connected, and I've connected those here. It doesn't actually matter with this sort of connection, the order of connection. It's entirely not important with the three-phase motor. Reason being, if you've got 3 identical phases, because each of those connections sees the other 2 from exactly the same perspective, so it's basically like a Y or star arrangement. So there is, no matter what order you put those in, as they cycle through, it will basically do the same thing. So you can think about it as you can have 1, 2, 3, and you can have 3, 1, 2, and as you repeat it, you will still get them arranged in order. The only thing that can change it will be the ascending or descending order, so it will just change the rotation of the spindle. So anyways, without more talking, let's see if this will rotate. So I'm gonna get the speed just a little bit of 0, and I'm gonna apply again the 5 volts. Okay, it is spinning. But somewhat slowly. Oh, other direction. I was using this, it's working so far. I was using this hard drive motor as a impromptu angle grinder. I guess not angle grinder, but you get the idea. This is just, it's a piece of sandpaper stuck onto it, and it's quite handy if you want to just polish some metal or whatnot, or some screws. Or let's see if I can find something. Yeah, so you can get it to a nice sharp point. I was using this before with the actual driver board for this hard drive. When you applied both 5 and 12 volts to it, it will actually just spin up the motor and spin it indefinitely. But it was just annoying that having to apply both voltages, and yeah, it's not ideal. So I'm doing 6 volts now, 6.6 volts, and it's drawing 350 milliamps. 7 volts, 360. 8 volts, 400 milliamps. It goes drastically higher as I apply torque to the spindle, but yeah, at 8 volts the queen seems quite beefy. The bearing on this on the hard drive is amazing. This will there's a little bit of rubbing over there, but this will actually spin for a very long time after disconnecting the power. So maybe what I could do to make it a little bit more visible on the camera. Oh, there we go, masking tape. So one more time, power on. Yeah, 8 volts, 400 milliamps, and it's doing the business. I wonder, should I go any higher? Most of the hard drives have got a 12 volt spindle, so I suspect this is a 12 volt, but I just really don't want to burn out this chip. Oh well, there we go. 12 volts. Whoa! There goes the masking tape. But at 12 volts, at full speed, it draws an amp. So I suspect this will get this poor little chip quite hot. Or maybe not. After a while of testing, I can tell already that those modules seem a lot more robust. I mean, I've done what I did with the other one, and the other one failed, and those that are slightly different. So just to compare the two, what's the most notable difference? Those have got ground plane across the whole front of the top of PCB. There is a big ground plane, and the back is also has got this arrangement of those 3 lines that's distinct on both top and bottom. Those are not as robust as those which have not got that divided plane in the at the bottom of the PCB. So the modules are good as far as I'm concerned. They do work. So what I had in mind for doing with this is to affix one of those to it. This is standard 115mm cutting disc, metal cutting disc. Now I wouldn't be cutting metal with this, but this will fit as a really long-lasting abrasive, just for an odd, you know, squaring a piece of something off and whatnot. And the idea is that I want to cut the casing off of it and mount a table at a right angle to it. So having that, I will be able to take a piece of material and push it just ever so slightly against this, and this will grind it at a right angle. Yeah, the only problem with that is the diameter of a hard drive disk, the inside diameter, is slightly larger than the cutting disk. So the cutting disk has got 22.23 millimeter inside, and this looks like 25 millimeter. Let's double check the measurement. Yeah, that's yeah, you can call that 25 millimeter. So, or an inch maybe, which is close enough. But yeah, this is, let's go back to metric. 22.25 millimeter inside diameter. So I need to make this fit somehow. Okay, so yeah, what I figured out is that the diameter of the disc is borderline, literally like a tenth of a millimeter smaller than the outside diameter of a circle that would go around the 3 screws that are holding it. So what I've gone and done is I just literally filed a little bit on the inside of the disc, literally just scored the metal lining, and that seemed to have allowed me to put in the 3 screws and hold the disc in place. So that's an easy way to fix it. Now, only temporarily though. If this was to work, I would use another like this, for example, on top of everything, but I would need slightly longer screws. But anyways, just for the testing, I've switched it on, and let me show you what happens. So I'm running this at 12 volts, 10 volts now, sorry, and so far so good, but this is really low. So as I increase the RPMs, this is not even really fast, but this already starts walking, and the wobble is quite significant. And I don't fancy continuing with this for a number of reasons. Well, this wobbles so much that it actually becomes scary. So it's almost I'm just worried. I've got a few things in the room, the fish tanks behind me, and if this was to fling off the screws, let go, and whatnot, this could be potentially really catastrophic. So this is one of those things that, nah, don't do it. So my instinct is telling me not to proceed with this. This is what I did. You can see this is literally just scored the disc inside, and that allowed me to make it fit into the, there's 1, 2 and 3. Now if I attach this in a very robust way, yes, it could possibly work, but the mass of the cutting disc is relatively quite large, and that would absolutely destroy the spindle. With such a high mass, not perfectly balanced, this would kill the spindle really quickly. The bearings would have just gone. So yes, back to this. So this will have to stay as a sandpaper contraption. I guess the sandpaper doesn't last as long, but you can always change it, so it's not that big of a deal. So through the magic of video editing, we are quite a bit some time later, and what I did is I cut the hard drive enclosure around, basically to remove all the excess aluminium. I did a flat cut over here, and I cut around the spindle on this side. I've got the wires connected as they were before, and what I did is a little simple wood jig out of this. I need to clean up the holes, and the idea is that I will be able to sit this over here like so, and the driver module will go underneath here, and I'll be able to power this up and use it as a right angle surface to do a little bit of filing on small things that I need to. Now to mount this, this is just pieces of wood I picked up from hardware store. This was like £1 for 2 meters, this wood, and I've just put a little bit of wood glue and screwed it in so it holds in place, holds together. And I've got 2 holes over here, and I've drilled and tapped holes in the hard drive case, the matching holes. So let's see how that fits in. Now it's quite a bit strange for me that I'm almost completed something and I'm not bleeding. But anything could change now. Okay, so that's pretty much assembled. I need to just work out how to mount this in here, connect the wires, probably shorten the wires quite a bit, and I'm thinking of power connector because I haven't got a spare jack. I might just because I was using crocodile clips, and most likely, to be honest, I will be using crocodile clips to power this up most of the time. So I'll just thread the wire and maybe put little loops of copper wire so I can clip on the crocodile clips too later on. And that's mounted in. The wires go round and are connected. I've shortened them up a little bit. I've put little spaces that I've cut out of my balloon holder stick, and just screwed it in, so I'll be able to access the speed control from the side. And yeah, all I've got left is to get the power posts. Okay, there we go. That's my epoxy grinder table completed. And yeah, I've just made 2 lugs out of wire and screwed them directly into the board and connected it up. And now, whenever I need to, I can just plug in crocodile clips from the power supply, and there we go. Now the sandpaper on this is quite worn out because I was sanding those blocks on this, but yeah, this is not very powerful, so this is a handy thing to have, at least for my use. I quite often find a tiny little bit of either metal or wood or plastic that I just need to square off really really precisely, and this will do the job. And it's a tabletop, small tiny thing that I can have on put on my bench, and it's relatively quiet, so I'm not gonna wake up my kids and neighbors and everyone else by launching a 300 watt grinder. So yeah, nice little tool from scrap. If you like the video, please make sure to give me a thumbs up and subscribe for more random stuff. As far as this one, that's all. Take care.